Now some more application. Now I'm gonna derive some relation between force and momentum, right? So the meeting is about to end. Kindly rejoin. Gonna just finish it out, and yeah, we'll take 15 more minutes. Okay. Kindly rejoin the time. So yeah, force and momentum. Okay. So the relation between force and momentum is basically as follows, right? That force is the rate of change of momentum, right? So if you recall the Newton's second law, can anyone tell me Newton's second law? What Newton's second law?
F equals to ma.
The definition. What about the definition in terms of word?
Yes, the second law of Newton's second law of motion describes as if you apply a force on a block of mass, an
Mhm.
acceleration would result as a product with the direction of that force.
Okay, good, right? So now I want you to focus on those words, and this is summarized basically as follows, right? F is equals to ma, right? So now I'm gonna pay quick attention. I'm gonna derive this, right? Okay, how do we go from here till here, right? So this is basically another representation of Newton's second law. Okay? So this is another representation, another form of Newton's second law. So let's say if you write this down, this definition in your Newton's second law, that will also be accepted, right? There's another, I can say, version of Newton's second law. Okay. So it states K, what is basically force? It states K, force is the rate of change of momentum. Okay, ji? This definition is pretty important over here, right? That force is the rate of change of momentum, right? Rate of means ke every any quantity which comes out the rate is going to be basically divided by time, right? That makes sense. But rate of what? Change of momentum, right? You can see delta P. Okay, ji? So this states ke force is equals to delta rho divided by delta T, right? Delta means change, right? And rho is momentum and t is time. So force is basically the rate of change of momentum, right? Okay, Ji. So impulse. Then we have impulse over here. So can anyone define K? What is impulse? Yes, give me an example of impulse.
Sir, impulse is when a resultant force acts on a mass. The momentum of that mass will change.
Yes, good. ठीक है, perfect, right? So this is again, this definition is same जो मैंने आपको बताया कि resultant force is the rate of change of momentum. Impulse is what, right? Imagine this. Let me just give you a real life example. That is, imagine that there is a driver who is driving the car, right? And this is, let's say, a Rolls Royce, okay? And the person is driving the car and he's sitting here on the wheel, okay? So now basically suddenly let's say he crashed into a wall, right? He crashed into a wall, okay? So what happens? His head basically hits the wheel, right? The contrast between the head and the wheel, right? Let me just draw the head. Let's say this is the head of a person. The contact is basically for such a small time, okay? That is delta t. So that is going to be, let's say, 0.0001 second. Okay, जी? And if you recall the formula of force, that is change in momentum, rate of change in momentum. Okay, जी? So if this part is pretty small, if this is really, really small, okay, let's say this is 0.000001 second. So this impact in such a short duration is called an impulse, right? And this can create serious injuries, right? So imagine, let's say, if a person fell down off his bicycle, right? And you can see his head, his or her head starts to bleed, right? So what happens when they fell? They basically they contact with the ground for such a few short of time, such that it impacts in such a huge way that it cracks either of the parts of the bone, right? So this impulse is very, can say, threatening in driving, right? So whenever a car is designed, or a bike is designed or a helmet is designed, so they always check their impulse response, right? How would the helmet, how would the car, how would the bike, okay, or how would the car is designed to basically absorb the impulse, right? So they want to minimize this, right? They want to minimize these cases to avoid such serious injuries, right? Does impulse make sense? If yes, give me a thumbs up. And what is the second representation of force? I derive the formula now, why it will make sense. ठीक है, कैसे formula है ये? Okay, good. Now let's derive, right? So let's derive this formula, that how it came into picture, right? So we have this formula which we have studied in your forces, that is Newton's second law, that F is equals to ma, right? We want to go from here to this new shape, that is F is equals to change in momentum upon change in time, right? How do we go from here till here, right? Okay, so before this, I'm gonna take some help from some equation which we have also studied before. So we define acceleration as follow, right? It is the change in rate or change of velocity rate, v minus u divided by t, right? Where u is what? U is your initial speed, right? Or initial, you can say velocity, not speed, initial velocity. Sorry, it is your initial velocity. Okay, G. So yeah, if you have any question in the derivation, just stop me there, right? At whatever step you get lost. Okay, my PowerPoint is just breathing its last. Okay, let me just rub this. So your this is initial velocity. Okay, U means initial velocity and V is your final velocity. Make sure कि आपको आता हो this derivation comes in your exam, right? And then T इसको बोल देते हैं हम delta T बोल देते हैं, right? So delta T is your change in time, right? Delta T is your change in time. ठीक है जी. Now let me put this form into this, ठीक है, into this equation, right? So what happens? This comes out to be F equals to M times V minus U divided by delta T, right? So if I expand this, it comes out to be as follows: that force is equals to mv minus mu divided by delta t, right? आप मुझे कोई बताएगा what is mv, what is mu? Yes, so we are at this position right now, that F is equals to mv minus mu divided by delta t, right? So if you just imagine, okay, there is a wall over here, right? There is a wall over here, and let's say the car is moving, right? ठीक है जी. It has certain initial velocity, that is u, and it has a mass of m, right? Let's say it hits the wall and it has some certain final velocity, and the mass is going to be same, right? So now using, चलिए इसको हटा देते हैं. Let me just give you a simple example ताकि it will make more sense to you guys. Let me just give you example of a tennis ball, right? This is your, let's say, a wall, and you are standing over here, you're trying to play with the ball, right? You throw a tennis ball, you throw a tennis ball in this direction, right? So it has a mass m, right? And it has initial speed of u over here, right? So after bouncing back, it goes in this direction towards you. Okay, it has a final speed of negative v now, right? Okay, so if I want to find the initial momentum of the ball, that is going to be what? The initial momentum is going to be mass
Final momentum
times
minus.
initial speed, right? Yeah. If I want to find the final momentum, that is going to be the mass times the final speed, that is going to be negative v, right? So it comes out to be negative mv. So if I want to find the change in momentum, okay, that is going to be what? Final momentum minus initial momentum minus final momentum, right? I want to find the change. It's going to be basically initial momentum plus final momentum, right? So that is going to be mv. Okay, एक मिनट. Okay, I just made a sign mistake over here. Okay, जी, v minus u over t, ठीक है जी. Yes, change is going to be this. Let me just take it this over here. This is going to be as follows, right? This is changing momentum over here. That is final initial momentum minus final momentum. Okay, sorry. Let me just fix it out over here. So the change in momentum is going to be as follows. The final momentum after minus initial momentum, right? Okay. So this is going to be your delta P, right? So what do you see over here? The final momentum, right? And what do you see over here? The initial momentum, right? So this quantity is basically delta P, that is mv minus mu, right? Therefore, your force is coming out to be what? It is the change in momentum divided by the change in time, right? So this is another representation of finding your resultant force, that is rate of change of momentum divided by time. Make sense?